Good morning, friends and my dear children. Welcome back once again to the most important study channel, that is Perry's Study and Motivation. Those who are seeing this video for the first time, please go through the videos which I have uploaded previously, and please give a like, a comment, a suggestion, and also please subscribe to my channel. That's a personal request to all of you. Right? This is Lalita Perry, okay, the science teacher. Basically, I teach chemistry. Okay, so today I am going to start a very important chapter in chemistry, that is for class 10th, and the chapter name is, I think you can expect, the periodic classification of elements. Okay, the very important chapter of chemistry. Okay, so it is a little bit a big chapter also. So we need to make so many videos in parts we need to make. Okay, so we are going to discuss about the very important and interesting topic of chemistry. Even from class 6th onwards, all children will be very curious to learn about elements. Okay, so we have a great opportunity to learn about elements, and the chapter name is periodic classification of elements. Right? So shall we start now? Okay. Right. So the chapter name is periodic classification of elements. Periodic classification of elements. This is for class 10. Okay. So basically I just wanted to give a small introduction about this topic, and in this video I am going to deal up to Newlands law of octaves. Up to there I'll teach in this video. The remaining concepts will be in the next coming videos. Okay. So I request all of you to please give comments and make the sessions to be more interactive. Okay, your comments and suggestions are going to be a very big support for new YouTubers like me. Okay, if you are going to support me in my journey, even I can do lot many wonders. Okay, so please request all of you to give suggestions, comments, your likes, and everything. Your subscriptions also are very precious for all of us. Right? Okay. So, introduction about periodic classification of elements. So, what is periodic classification? So, first, before I'm going to introduce about this periodic classification, I'll just tell you a small daily life situation. Okay, where we'll come across certain classification. Okay, so suppose if we go to a medical shop and if we ask for a tablet, okay, then the person who is there in the medical shop will pick the tablet from the right rack, and he gives you within no time. Okay, and another person, if he comes and asks for another tablet, okay, then immediately for him he picks from another rack, and immediately he handovers the tablet or medicine or cough syrup, whatever it may be. He hand it over to the respective person without any lapse of time. How can he do that? You might have seen in a medical shop, so many racks will be there, and in different racks, okay, already the medicines were arranged in a particular order. Okay, the same situation you can even observe in supermarkets also. Okay, if you go to supermarket and if you wanted to buy some biscuits or chocolates or whatever it may be, and if you go there, you need to search for so many things. Okay, just if you ask that shopkeeper or the person whoever available over there, immediately he picks up the thing whichever we want and he gives that thing to us. Okay, how can he do that? Because everything that have been arranged, okay, in a particular order. Okay, so there is a need for arrangement of certain things, okay, in our daily life also, isn't it or not? If everything seems to be clumsy, definitely we don't feel like using that things also. Okay, in our house also, everything we have to keep them arranged, okay, in a particular order. Then we can understand as well as we can use that particular things in a right manner, isn't it or not? Okay, right. Now, periodic classification of elements. Okay, so here there is a lot much need is there to classify the elements. Okay, so first of all, I just wanted to give you a small introduction about elements. What is an element? Okay, so elements. First, let us learn about elements. Elements. So elements are defined as the basic form of matter which cannot be broken down into simpler substances. It is defined as what? The basic form of matter. The basic form of matter which cannot be broken down. Which cannot be broken down into simpler substances. Broken down into simpler substances by chemical reactions. Which cannot be broken down into simpler substances by chemical reactions. This is what the definition for an element. Okay, it's a basic form of matter. Okay, it is the simplest form of matter which cannot be further broken down into still simpler substances. I am not speaking about the particles present inside the element. Okay, element is a basic form of matter. Any kind of matter you take, whether it is a solid matter, a liquid matter or a gaseous matter. Okay, it's a basic form. Okay, element is defined as the basic form of matter. And this definition was first given by whom? Robert Boyle. Okay, Robert Boyle. Okay, Robert Boyle, I think in 16th century, almost around 1661. Okay, in 16th century, okay, he discovered, okay, that so and so matter exists in the form of elements. Okay, so Robert Boyle has given the definition for an element as what? It's a basic form of matter, okay, which cannot be further broken down into simpler substances by chemical reactions. Okay, so this is the definition for what? Element. Okay, so at the time only 13 elements were discovered when Robert Boyle came to know about elements. Okay, only 13 elements were discovered. Okay, later in 18th century, maximum up to 55 elements were discovered. Okay, and now we have 118 elements. Some are already discovered and some were synthesized in the laboratories also. Okay, so this is the definition for what? Element. So what are the examples for elements? We come across so many elements in our daily life, isn't it? The element which we inhale is what? Oxygen. Okay, so the pen with which I am writing consists of ink. Ink consists of what? Carbon. Carbon is an element. Okay, everything, whichever be the type of matter it is made up of one or the other element only. Okay, so we are going to discuss about elements, their properties, okay, nature of their that elements we are going to discuss, okay, as well as periodic properties of elements also. Okay, so all about the classification of elements, the properties of elements, physical and chemical properties of some elements, and periodic properties of elements, and how these elements are arranged in periodic table. Okay, how many scientists have contributed, okay, for the arrangement of elements in periodic table. So what is periodic table? Okay, periodic table is the arrangement in which all the elements have been arranged in a particular order. Okay, so many scientists have done their best. Okay, many scientists have kept their efforts to classify the elements in a particular order. So we are going to learn about all the classifications that have been given by different scientists and the drawbacks that have been given by that scientists. Okay, everything we are going to learn in this chapter. So we can enjoy the chapter a lot. Isn't it, children? Okay, anything which you learn, I request all of you to please make notes. Okay, make notes of whatever you are learning and keep writing and practice it day to day. Okay, up to date practice if it is there, that develops your vocabulary also. Okay, so let us move on to the topic. What is the need for classification? Why classification is required? As just now we have learnt the example of what we call medical shop or the example of supermarket. We have learnt. Okay, much necessity is there. Necessity is there to classify the elements. If they are not classified, how can we learn about the properties? How can we learn about their uses? How can we learn about their importance in nature as well as in industries in so many fields? Isn't it? So there is a much necessity is there to classify the elements. Need arises to classify the elements. Okay, compulsorily classification is must, isn't it? Okay, so let us learn. The first attempt to classify the elements was first made by Dobereiner. Okay, Dobereiner is the name of the scientist. Okay, the first attempt to classify the elements was made by the scientist named Dobereiner. Okay, so he gave a law which is called as Dobereiner's law of triads. Dobereiner's law of triads. I think you all know. Triad means what? A set of three elements. Okay. So whichever the elements which are available at that time. Okay. He classified the available elements which are available at that time. He classified them into three sets. Okay. Set of three elements, not three sets. Set of three elements is termed as what? Triad. Okay now. So, law of triads. In what way he classified? In what way he arranged them as a set of three elements? Okay. So, what is that law states? So, law of triads states that Dobereiner arranged the elements in such a way that, okay, set of three elements arranged in such a way that the arithmetic mean of, okay, terminology and definitions are very important. Okay, so please be very careful with the terminology which you have to use. Okay, so the arithmetic mean of atomic weights of first and third elements is equal to what? Is equal to the atomic weight of middle element. Okay, is equal to the atomic weight of the middle element. Okay, so he classified the elements based on what? Atomic weights of elements. Okay, atomic mass or atomic weights of elements. Okay, I think you all know. Atomic mass is the total number of electrons, protons and neutrons. Okay, inside the nucleus, protons and neutrons are there. So the total number of protons and neutrons present inside the nucleus, you call it as its atomic mass. Okay, so he arranged the elements in such a way that three elements were made as one set. Okay, set of three elements. In such a way he arranged that arithmetic mean. Okay, arithmetic mean of what? Atomic weights of first and third element. Okay, arithmetic mean of atomic weights of first and third elements. Okay, is equal to what? The atomic weight of middle element. Okay, so three elements are there, ABC. Three elements are there, ABC. Atomic weight of A plus C by 2 is equal to atomic weight of B. That is what he was telling. So he arranged the elements in that way. And that law, you call it as what? Law of triads. Okay, so let us learn the examples for this. So what are the examples? Examples for what? Examples for Dobereiner triads. Examples for Dobereiner triads. Okay, so let us learn the examples. So first example, example 1, lithium Li. Lithium is an element. Sodium Na, natrium. Sodium, natrium. Symbol is Na. And potassium, K. Lithium, sodium, potassium. Okay, lithium, sodium, K. K means what? Collium. Potassium, right? So these three elements, set of these three elements is considered as what? Is considered as triad. Okay, so here you can see the atomic weights of lithium and sodium, lithium and potassium. Atomic weight of lithium is 7 and that of potassium is 39, right? So if you take the arithmetic mean of these two, 7 plus 39 by 2, how much you will be getting? 7 plus 39, 46 by 2, which is equal to 23, right? So sodium's weight is also 23, isn't it? Arithmetic mean of first and third element is equal to the atomic weight of middle element, second element, right? So let us learn example 2. Okay, example 2. I think you can see the board, right? Example 2. So what is the second example? So second example is chlorine, bromine, iodine. Chlorine, bromine, iodine. Chlorine atomic weight is almost around 35.5. Okay, and iodine's atomic weight is almost around 127. Atomic weight of iodine is 127. Right? If you take the arithmetic mean of these two, you will get the atomic weight of bromine. How much is the atomic weight of bromine? Almost around 81, 81.5, something like that you will be getting. You take the average of these two, 35.5 plus 127 by 2. Okay, how much is this? 127 plus 35. Okay, 12, 165, 162.5 by 2. It is almost around 81.25. The same is the atomic mass of bromine. Br means what? Bromine. Please remember the names, children. Chlorine, bromine, iodine. Br means bromine. Iodine. I means iodine. Here lithium, sodium, potassium. lithium, sodium, potassium. First example, right? And let us learn one more example. Shall we learn one more example? Calcium, strontium, barium. You can take another example. Example 3. Can you able to see the board? Yes. Example 3. Calcium, strontium, barium. Calcium, strontium, barium. Calcium atomic weight is 40 and barium atomic weight is almost around 137. Okay, 137. If you take the average of these two, you will get the atomic weight of strontium. Okay, so 40 plus 137 by 2. How much it is? 40 plus 137 by 2. 177, right? 177 by 2. So it is almost around 88.5. 88.5. So strontium weight is also 88.5. So the set of three elements. What are these? Lithium, sodium, potassium. Okay now. Chlorine, bromine, iodine. And then calcium, strontium and barium. So these three are the examples for Dobereiner's triads. So these three are the examples for Dobereiner's triads. You can even take the examples of sulfur, selenium, tellurium. Okay, example 4 you can take. Example 4, sulfur, selenium, tellurium. Okay, and even you can take the example of phosphorus, arsenic and antimony also. Example 5, phosphorus, arsenic, antimony. Okay, so like that you can take these 5 as examples. And this classification is not valid for higher elements. Elements with higher atomic weights. Okay, Dobereiner triads is not valid for the elements with higher atomic weights. Okay, so that was a drawback. Okay, so if you go for higher atomic weight elements with higher atomic weights, if you go for, okay, most of the elements you are finding them to have similar atomic masses. Okay, now you can take the example of iron, cobalt, nickel. Okay, iron, cobalt, nickel is not a Dobereiner triad. You will be getting this as a 2 marks question. Iron, cobalt, nickel, not a Dobereiner triad. Iron, cobalt, nickel. No, because here cobalt and nickel. Okay, now cobalt and nickel almost will have similar atomic weights with 0.5 differences. 58.5, 58.9. Okay, something like that. Very minute difference is there in atomic weights. Then this law of triads is not applicable. Okay, so iron, cobalt, nickel, triads concept not applicable. Concept of triads is not applicable. Okay, same like that, ruthenium, rhodium, palladium. Okay, not applicable also they will ask. Ruthenium, rhodium, palladium, not applicable. Because they are having what? Similar atomic weights. Not applicable. Okay, similarly osmium, iridium and platinum. Osmium, iridium and platinum. For this also, Dobereiner triads concept means arithmetic mean of atomic weights of first and third is not equal to the middle element's atomic weight. Not applicable. Okay, so give examples for the triads. Give examples for the set of 3 elements in which triads concept, Dobereiner triads concept is not applicable. That also they may ask a question. You can take these 3 examples. Set of 3 elements. This is first example where Dobereiner triads concept is not applicable. Okay, similarly ruthenium, rhodium, palladium, osmium, iridium, platinum, right? So this is all about what? Concept of Dobereiner Triads. Classification was based on atomic weights, okay, but it is not applicable for the elements with higher atomic weights. Okay, that's why this model has been failed, right? So if it is failed, another person has to come into picture, isn't it or not? So who is that person who comes into picture? Okay, so that person is Newlands. Newlands. Okay, so Newlands law of, next comes what? Newlands law of octaves. Newlands law of octaves. So what is octave? Newlands is the name of the scientist. Octaves. We know about octaves in music. Okay, the 7 musical notes which we know in music. Sa, re, ga, ma, pa, da, ni. You all know about them, right? So here also he took the concept of octaves. Okay, and the classification was made. It was made based on atomic weights only. Okay, so the arrangement of elements was done in such a way that if he arranged the elements in a particular order of their atomic weights, okay, then first element resembles in properties with the next coming 8th element. Please understand carefully. See, in musical notes also you will find sa, re, ga, ma, pa, da, ni. After ni, again you will start with sa, sa, re, ga, ma, pa, da, ni, sa. Something like that you will start, isn't it? So again sa is getting repeated after ni. After all the 7 musical notes have been uttered, again as an 8th note you are giving sa only again. That means sa is getting repeated, isn't it or not? Sa is getting repeated. So in the same way he arranged the elements as a set of 8 elements in such a way that first element resembles in properties with 8th element. Please remember that point. First element resembles in properties with 8th element. So let us learn the examples. Okay, now, so what does Newlands law states? Okay, Newlands law. What does the law states? The set of 8 elements. The set of 8 elements. Okay, now 8 elements arranged based on what? Atomic weights. Based on atomic weights. Arranged in such a way that the first element resembles with 8th element. Okay, in such a way that the first element resembles in properties with what? With 8th element. First element resembles in properties with 8th element. Okay, so what does he tells us about? Okay, so let us learn the example. We'll learn it in the form of a table. Okay, now, so you all know about the 7 musical notes are arranged like this: sa, re, ga, ma, pa, da, ni. Okay, so elements also. Elements based on what? Atomic weights only. Please remember, elements based on atomic weights. Okay, so how he arranged? So let us learn 1, 2, 3, 4, 5, 6, 7. Okay, so now let us learn about the elements. Okay, hydrogen, atomic number 1, you all know. Sorry, atomic weight also 1 only. Hydrogen atomic number and weight, both are 1 only. So hydrogen. Then comes actually helium, but helium is an inert gas and some of the inert gases were not yet discovered at that time. Okay, so he did not consider inert gases. Now we know about inert gases, but at the time when Newland made an attempt to classify the elements, at the time inert gases were not there, so inert gases were not taken into consideration, right? So next, after helium, what is the element? Lithium. Okay, lithium, beryllium, boron. B means what? Boron, carbon, nitrogen, oxygen. Okay, then what is the next element? After oxygen, fluorine. Then comes neon. Neon is again an inert gas. So inert gases we should not take into consideration. Please remember that point. Don't take inert gases into consideration. Okay, we know about inert gases now. But at the time when he made the attempt, inert gases were not yet discovered. Okay, so after fluorine, neon actually will come. But now don't take neon. After neon, sodium. Okay, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. Okay, and then comes what? After sulfur, chlorine, isn't it? Chlorine. After chlorine again, argon. Argon is an inert gas. So inert gases we are not taking into consideration, right? So chlorine, after that we'll take potassium and then calcium. Okay, after calcium actually you all know scandium will come, but scandium was not discovered. Okay, so what was the element which was available at that time? He arranged them based on atomic weights. Okay, so after calcium he arranged chromium. Okay, then manganese. Manganese was available at that time. Iron was available at that time. Okay, titanium was available at that time. Chromium based on atomic weight. Okay, titanium, manganese and iron. So he classified the elements like this. Okay, so now listen to the concept carefully, right? So after the arrangement of 7 elements has finished, the next element was fluorine. So hydrogen resembles with fluorine. Okay, and then fluorine resembles with chlorine. So these elements have similar properties. Okay, now similar properties. Hydrogen, fluorine, chlorine. Hydrogen, fluorine, chlorine. All three are gases. Okay, similar properties are there for them. Okay, so these 3 elements comes under one group. In that way he was arranging. Okay, similarly lithium, sodium, potassium, same properties. Okay, and then beryllium, magnesium, calcium, same properties are there. Right, dear children? Then boron, aluminium, chromium. Chromium a little bit it differs in properties with aluminium. Okay, but of course aluminium is a metal, chromium is also a metal. Okay, so in that way some similarities are there. Okay, so these also comes under the set in which Newland's law is valid. Now look at this: carbon, silicon, titanium is also okay. They are also having a little bit similarities in their properties. Properties means what? Chemical and physical properties. Okay, please remember. But here nitrogen, phosphorus, manganese, I think you are not able to see the cross mark which I kept here. This is cross. Wrong. This arrangement is wrong. Okay. Then oxygen, sulfur, iron. Oxygen, sulfur both will be resembling in properties, but iron no way resemble in properties with oxygen and sulfur. In the same way, nitrogen, phosphorus are having similar properties, but manganese no way related to the resembles with the properties of nitrogen and phosphorus. That means the law became invalid here. He arranged the elements in such a way that first element resembles in properties with eighth element. Coming eighth element, succeeding eighth element, please remember. Okay, eighth element for oxygen is sulfur, it is resembling. Next coming eighth element for sulfur is iron. At the time, whatever the elements which are available at the time, based on that he classified. So sulfur no way resembles in properties with iron. Okay, but based on atomic weights he arranged. Okay, so that was his drawback. Okay, so let us summarize the drawbacks of Newlands octaves also. Okay, let us summarize the drawbacks. What are the drawbacks? Up to some elements this law is valid, but it is not valid for higher elements. Okay, now elements with higher atomic weights, it is not valid. Okay, so drawbacks. Drawbacks of Newlands law. Newlands law of octaves. Newlands law of octaves. What are the drawbacks? Okay, so what are the drawbacks? So first one is what? First one is it is valid up to certain elements only, up to atomic weight 55. Okay, up to atomic weight 55 it is valid. Up to calcium it is valid. Very clearly. Up to chromium also. Up to chromium also it is a little bit valid. But here onwards the properties are totally indifferent. Okay, so that's why the first thing is what? Manganese placed along with what? Nitrogen and phosphorus. So it's a wrong placement. Same like that. Iron placed along with oxygen and sulfur. So this is also wrong placement, isn't it? And then dissimilar elements were placed together. Okay, so that means what? These two tells you about what? Dissimilar elements were placed together. Dissimilar elements were placed together. Okay, dissimilar elements were placed together, and he did not leave any gaps. Some elements were known at that time. Okay, but their atomic weights were not discovered, or he didn't leave some gaps also. He keep on arranging like this, and this went wrong. Okay, so wrong positions. Okay, wrong positions. Space was not left. Okay, no space was left. No space was left for other elements. No space was left for other elements. Okay, so like this, his many elements were provided wrong positions also. Okay, so this may come for 2 marks question. Okay, many elements were in wrong positions. Okay, many elements were in wrong positions. Okay, wrong positions. So that's why. Okay, so the law valid up to atomic weight 55. Atomic weight 55 only. So for further elements the law was invalid. Okay, so these are the drawbacks. So please remember these points. You will be getting this question for 2 marks. The law will be asked for 1 mark, and sometimes what are the dissimilar elements which are placed together and all. Okay, so like that, drawbacks also they will ask for 2 marks question. Okay, so please remember these points. So up to here I am going to stop the video. Okay, you please keep learning, keep continuously be in touch with the concepts. Okay, keep memorizing the concepts. Otherwise, exams are nearing and so many disturbances with this COVID situations which are there nowadays. Okay, nothing happens to us. Okay, please keep your concentration totally on studies. Okay, so definitely your hard work will give you better results. So always I say what? Your hard work is your superpower, isn't it? So be confident and believe in your hard work. Okay, so thanks for watching and bye.